Different printing technologies are capable of printing different ranges of colors. For example, if you've got a box of crayons, you can lay down a broader range of colors than you can with a box of pastels. Now, I'm not talking about number of colors. Sure, with a box of 64 crayons, you have more separate colors than you get in a box of 12 pastels. What I'm talking about is range of color. With the crayons, you can create darker, richer colors than you can with the pastels, but you still have access to lighter colors as well. With pastels, all of your colors are fairly light and unsaturated. They are, in fact, pastel colors. We refer to the range of colors that a particular technology can produce as that technology's color gamut. So a box of crayons has a bigger color gamut than a box of pastels. Similarly, a printer has a specific gamut of colors that it can print, while a camera has a particular gamut of colors that it can capture. A particular paper has a gamut, as does a specific monitor. Different types of printers, cameras, papers, and monitors all have different color gamuts. That should be pretty easy to understand. But because all devices have a different gamut, and because all of those gamuts are a different gamut than what your eye has, things really get complicated. Here's why. Let's say I take a picture with my camera and it decides that the color of this cup is the brightest red that it can capture. In other words, the camera decides that this cup is 100% red as far as it's concerned. It is the red that sits on the extreme red end of the camera's gamut. For the specific pixels in the image that represent this cup, the camera socks away whatever number it is that represents 100% red. That's all well and good, except that 100% red doesn't tell me anything useful. There are a lot of reds in the world. Which one is 100% red? On its own, the camera's color information doesn't really mean anything. Before the data 100% red can be useful, we need to know a specific color of red that value corresponds to. And so we map the colors in the image into something called a color space. A color space is nothing more than a standard that defines a specific set of colors. When we map the colors in our image into a color space, then the color values that our camera captures have specific meanings. Now, you may not know it's been doing this, but your camera has been mapping its colors into a color space all along. Most SLRs offer a choice of two color spaces, sRGB and Adobe RGB, and most cameras default to sRGB. sRGB is a color space that was defined by Microsoft and HP in 1996. It specifies a range of colors that's a little bit small. What's nice about the sRGB color space is that all of the colors specified by it are within the gamut of most people's monitors. In other words, there's probably no color specified in the sRGB color space that your monitor can't show. So if the colors in your image are mapped to sRGB, there's a good chance that your monitor will be able to show you a very nice version of your image. But you won't necessarily be getting the best image that you can out of your camera. And to explain why, I want to show you something. In the last movie, you learned about the idea of a color model, and you learned that in RGB and HSL color models, colors are represented by three numbers. This is called a tuple. Because colors are represented by three numbers, there's a way that we can visualize a color space. We can simply take each tuple that defines the color space and graph them all as coordinates in 3D space. So for example, we might graph the red value of a color on the x-axis and green on the y and blue on the z. This should be familiar to you. It's just basic high school geometry. If we graph all of the colors in a particular color space this way, then we can see a visual representation of the size and range of that space. And that's what I've got right here. This is a graph of the sRGB color space. So what you can see is that, and I can rotate this around, this is a piece of software called ColorThink, and it's a really nice analysis tool for learning more about what your monitor and your printer and your camera are capable of. So you can see that sRGB gives me a nice range here into blue, and I've got reds, and I've got some greens. So my darker colors don't go super dark. My light colors go all the way to white. So this looks pretty good. But if I switch my camera over to the Adobe RGB color space, then right away, pictures that I take will have brighter reds and greens and maybe a few extra blues. And here's why. Watch what happens if I stop this and bring up a graph of Adobe RGB. So this is the Adobe RGB color space. If you look down here at the bottom, you can see this line is the extent of sRGB. This line is the extent of Adobe RGB. I'm going to turn down the opacity on Adobe RGB, and there you can see that the sRGB color space fits entirely inside the Adobe RGB color space. I get all this extra bright green out here with Adobe RGB. I get a lot of extra reds. About the only thing that's the same is over here is on the extreme ends of my blues and magentas, there's not a lot of difference. But on every other axis, I get a lot more colors out of Adobe RGB. Now, whether I will be able to see any of those extra colors on my monitor or on the printed page, that's a different story, and we'll get to that later. But if you've got a new monitor, you will probably see an immediate improvement in the color of your images by switching your camera to Adobe RGB. Now, at no time are the actual color values in my file altered. Pixels stored as 100% red are still stored as 100% red. When my camera writes out the file, it simply makes a note in the file's metadata that says that this image should be mapped to either sRGB or Adobe RGB, depending on what I chose in my camera setup. The file is tagged with that particular color space. When I open an image in Photoshop, Photoshop understands that it should map the color values to the color space that is specified in the file. This means that I can change the color space at any time. Photoshop will simply remap the colors. Let's take a look at that. I'm going to switch over here to Photoshop where I have an image open. This image is currently tagged as an sRGB image, so all of the different color values are being mapped into that sRGB space. Watch what happens if I go up here to the Edit menu and down to Assign Profile and change its profile from sRGB to Adobe RGB. Keep an eye on these colors in here as I make the change. Boom. A lot of them just got a lot brighter. My reds got brighter, these blues got brighter. All of those colors that we saw had more space in Adobe RGB have in fact brightened up. I haven't done any image adjustments or anything. This is simply how different it can be when you map into one color space or another. Now, there are larger color spaces than Adobe RGB. Photoshop, in fact, provides a color space called ProPhoto. Let's go back over here to ColorThink and open up a new graph here. I want to show you the difference between here's Adobe RGB and here is ProPhoto RGB. ProPhoto is enormous. Look at all this extra color that I get around here on the edges of ProPhoto RGB. Again, there's a little bit of overlap with blue, but I get far more greens, yellows, reds. It's a much bigger color space. So why wouldn't I choose to be in ProPhoto all the time? And is it possible to have a space bigger than ProPhoto? And if so, why not use that? If I map colors into a larger color space, they spread out. I have the same number of tones to spread across a larger range of colors. This can mean that gradients in my image, skies, reflections, subtle shadows, those areas can develop visible bands. Also, if the conversion of a particular color from a small color space to a large color space is great enough, I might see a noticeable shift in color. Let me show you what I'm talking about. Watch what happens to this image. Actually, I'm going to zoom in on this. I want you to watch the hat here as I switch from Adobe RGB to ProPhoto RGB. Again, I'm going to assign profile in Photoshop. And again, this is not changing any of the data in my image. It's simply reinterpreting it. So watch in here as I go from here to ProPhoto, boom. This has shifted from red to almost being orange. I've actually lost some subtle detail in here. I'm going to go back to Adobe RGB for a minute. There's some intermediate tones that are defining some shadows that go away when I switch to ProPhoto. Also, just in general, the colors have become really overdone. They're looking kind of neon. This was a dimly lit room. Colors were not this saturated. So though this is a larger color space, it's not really working in my favor. So in general, I really recommend working in the Adobe RGB color space. It's a really good size for most of the work that you'll do. It's got more colors than sRGB, but not so many that you'll encounter the problems that you might face with a really large color space. There might occasionally be times when a switch to ProPhoto will give you a better image, particularly if you're having trouble with overexposed colors. But if your camera offers the option, set it to Adobe RGB. You'll also want to configure Photoshop to work in Adobe RGB, but we'll discuss that later. We're going to be talking about color spaces for as long as we discuss colors, so just remember, a gamut is the range of colors that a particular device can capture or show, and a color space is a predefined specification that delineates a particular group of colors. We map the colors from a particular device into a particular color space so that the color values correspond to specific colors out in the real world. Unfortunately, as you'll see in the next movie, there might be times when the gamut of one of your devices is smaller than the color space that you'll be working in.
A membership to lynda.com unlocks this entire course and hundreds of others. Visit lynda.com to learn more.